For anybody who's new to webinars, everybody will be muted on the call. However, down the bottom right-hand side of the webinar panel is a question and a chat window. So for any questions you want to ask, please feel free to type them into the question box. And at the end of the presentation, I'll open up the floor to some Q&A and try and answer some of your questions, or go back a few slides and re-go over some of the stuff I've shown. If you do want to send any questions after the presentation, I've provided my email address here down the bottom of the presentation slide here, samuel.mcallister@autodesk.com. So please feel free to email me afterwards with any questions or for any information you might need on some of the workflows that we're showing today. So it is going to be all PowerPoint just because of the way Citrix works. If you try and push videos or live demos through, it doesn't tend to like it. So we're doing the PowerPoints, but they are screenshots of actual workflows. And if you want to see recorded workflows, we could arrange to have those recorded and put up on our Autodesk ANZ YouTube channel. So the three parts to this presentation today are going to be doing a simple import of Revit into Infraworks 360. And to make it really fast and simple, I'm going to export the data as an FBX file format. So it's going to transfer the geometry and the material through, but it won't have to convert it inside of Infraworks 360. The second part, we're going to look at how to do the setup or the location of the Revit data. So inside of Revit, we've got the internet mapping service. So let's say you haven't got your detailed coordinate system set up, you can still intuitively use the internet mapping service and have that data transferred through into Infraworks, and it will come in the right location. And then finally, the more detailed setup, this is setting up your Revit model with a project base point. And for this presentation, it's going to be based on the map grid of Australia, Zone 56, because the building in question is going to be located in Sydney. And I'll do a bit of a deeper dive on that, how we can get information on the map grid of Australia, how we set it up in conjunction with other applications like Civil 3D and Infraworks 360 application. So a bit of background on who am I. I'm not a civil engineer, I'm actually an architect. I've been in Sydney now for about 5 years, just coming up to 6 years now. I was an architect in the UK for about 10 years, working in some large projects, including large master planning projects. I've worked in New Zealand, United Kingdom, Australia, Europe, and also projects in the Middle East. The companies I worked for were big global accounts. So some of you might recognize their companies like HOK and Building Design Partnership. And what was interesting in working in the UK is that the partnerships were always set up with major contractors on day one. So the great thing about being involved in a building information modeling workflow is that the contractors are at the table with us, and the data we designed was leveraged by the contractor for field operations and manufacturing and facilities maintenance and management. The type of buildings that I was involved with were schools and university projects. A lot of master planning went into some of these projects. Winning work was crucial when the GFC hit Europe, when all the banks went under. We were doing bidding for large projects in Qatar, in the Qatar desert, master planning military hospitals. And the ones that survived the banks falling over were the government funded projects. So healthcare projects and laboratories were still quite strong. The one on the left there is the Brighton 3Ts trauma hospital just outside of London. And the one on the right, which is now complete, was for the Medical Research Council for the University of Cambridge. And then now at Autodesk, I don't get to build real life projects, but I do get to work in a virtual world. I was fortunate enough to design the data set that actually ships with Revit. And on the screen here, this is the original data set, which has a bit more detail in it, but it's just an example of how much detail you can go to inside of Revit. It's not just taking it to a certain scale. You can actually go down to 1-to-1 should you want to. So moving up to a much larger scale, well beyond one-to-one, I want to go over these three plays. So one's going to be working with FBX data from Revit, and this is going to be the simplest one that anybody can pick up really quickly. The next one is going to be looking at using the internet mapping service inside of Revit to locate the building in its real-world location by doing a search address or even putting in latitude and longitude coordinates. And then the final one is going to be working with an actual project base point. So we're going to be able to set in our northings and eastings, our elevations, and our angles to true north. So a bit of background to anybody who might be new to this. Maybe there's some architects on the call who aren't familiar with the Map Grid Australia. This is the one that I'll be working with today for the more detailed Revit Infraworks 360 workflow. I'll be working with the GDA 94, the Map Grid of Australia. This is the geocentric datum for Australia. And down the bottom here, you'll see the zone that I'm working in is the 56 zone along the east coast of Australia. If you want to know more about this, about how to work with this data, how to bring it into your other applications, or find out just what all this means, because there's several different versions of the Map Grid of Australia for this region. If you go to the lpi.newsouthwales.gov.australia, there's some information on surveying there. For the Civil 3D users, you'll be familiar with this type of setup where you'll set up your units and zone information. You'll be working in meters, and you'll be actually able to grab that Map Grid of Australia Zone 56 with the GDA 94 datum directly from the product. So with these AutoCAD-based Civil 3D applications, it's going to be able to locate the buildings anywhere in the real world, and it's going to be available inside of the Civil 3D product. Now, this doesn't exist inside of Revit. However, there are some ways to bring that information in from this application to Revit and have them align. The one on the right here, this is a screenshot of Autodesk Infraworks 360. And again, you can set up your Australian Map Grid of Australia 56 coordinates with the actual GDA 94 datum to align with your Civil 3D and your Revit data. So by default, inside both these applications, you've got real world information that you can use to build up your site model and then bring in your Revit model to these exact coordinates. So this is just a quick snapshot of what it looks like inside of Civil 3D. And one thing to note is there may be several different versions of the zones to choose from. So it's good to do your research, to work with a civil engineer who can help instruct you with the setup here, because you can see it can be a bit confusing if you're not familiar with the coordinate systems. Inside of Infraworks, when you set up the model, you'll go through setting up. You can use Model Builder to build the site, but if you're building it from scratch and you're bringing in your own data, your own aerial maps, you'll set up a database before firing up the environment. So here, when I go to do a new model, over here on the left, I'll have my model name, my location, and it's a good idea to manage folders, put it in a location where you can store a large amount of data. You'll go to your model extents, which you can define. This can be defined also in Model Builder, but you can start to even load in a shape file if you want to have a shape defining the perimeter of your model extents. You can also work with Nearmap. This is a local Australian imagery service where you can get aerial maps and you can bring them in. There's a workflow that we have on the Autodesk ANZ YouTube channel showing how you can work with Nearmap, create a shape file with Nearmap inside of Civil 3D, and then use this for your perimeters inside of Infraworks. And then because I'm working with real world coordinates here, I want to be using my UCS and database setup here on the Map Grid of Australia 56. So there's a few notes here on what it means when you start to do this. So these are just good practices whenever you set up a model. If you're wanting to work with Revit, bring it in with real world coordinates, you need to have these set up. And then the last little bit over here is your design standards. We drive on the left-hand side of the road, so ensure you have that set up to metric as well. A couple other points. This is under the hood. So when you bring in your Revit or Navis or civil-based information, make sure you have the data import section here turned on to say Navisworks based local import. And this means that the file imports here will work. If you try and repeat this play, try and use this workflow, and if this isn't turned on, it won't like it. You'll get an error message. So just make sure you've got these turned on. If you need to find this inside of Infraworks 360, you can go to the spanner and the screwdriver and go to your application options. And this is where you're going to see a lot of control for your application. Infraworks 360 will also bring in numerous file formats. So these are just the top parent hierarchies of the file formats you can bring in. So when you go to click on 3D model, there's numerous different versions of 3D models that you can bring in. It will also work with IFC, LandXML, point cloud data, raster imagery, and SketchUp files. So it will start to convert the SketchUp data as well. So if you want to bring in buildings from the 3D warehouse, that will come through as well. If you need to find the import data sources, I'll show you on a few slides later, but this is where you can bring all that information in. So the first section we're going to start off with, this is going to be the easiest workflow that I'll be showing today. This is exporting out Revit as an FBX file format. And for those of you who aren't familiar with Revit, I'll show you some screenshots on this. So even if you get a Revit model from another consultant, from an architect, from an engineer, and you're not familiar with Revit, I'll show you some screenshots on how easy it is to grab that information, convert it, and then place it inside of Infraworks 360. So there'll be 5 sections to each of the 3 main sections. The first one is going to be exporting. Second one will be importing. The third part will be how to simplify the model. Sometimes you'll get a Revit model that could be 500 megs, or some people even do it as a gig. Don't bring in a gigabyte size Revit model into Infraworks. Try and simplify it if you can. You could take it via FBX into 3ds Max and use a Pro Optimizer to clean up the geometry, or there's a simplified tool inside of Infraworks as well to reduce the polygon count. There's a very simple interactive placing tool. It's just point and shoot, close and refresh. And then finally, if you need to manipulate that model, there's options to rotate and scale the geometry you bring in. So FBX export, it's pretty simple. You go to open up your Revit model, you mean a 3D view, and then go export, and you're going to get all these different types of file formats you can export to. So a Navisworks cache file, or your CAD formats, etc., IFCs. The one I'm using today, you could use several other ways of doing this if you wanted to, but I prefer to use the FBX. The reason I prefer to use the FBX is because it's going to hold the texture mapping from Revit as well. So if you want that information to come through, FBX is a really good way to transfer the data. There's also a couple of options here where you can choose manual or automatic short naming conventions. So if you want to keep the same name but you want to shorten it, or if you want a lot more information, you can start to choose these for the naming. So it's a really easy export. The import, this is going to be the part where if you're not familiar with Infraworks, you just got to follow some basic steps here. So number one, we have, with most Autodesk applications, you work from left to right. So the first menu here, the orange eye, is going to have this first tab you're going to bring up. This is selecting data sources from this first graphic here. And when you bring up data sources, it's going to be able to, let's bring this across a little bit, bring up this menu here on the right where we have options to import different types of data. So the little white paper with the green button here will be your import section. And then when you import it, it's not going to be configured to fit into any of the folders here. So down on the right here, we've got folders for buildings and city furniture, etc. What you need to do is double click on the object and then configure it to place inside of your model, and then it will go into the right folder and it will go into the right locations. So by double clicking on that default import, so with that double clicked, you're going to get some options. You're going to get this pop-up option here, and it's going to have 3 tabs. It's going to have geolocation, tooltip if you want to add that, and also this one here, which is the 3D model, which will give you a viewer of the Revit data. And you're going to choose buildings, because by default the description there will be empty, so choose buildings. And again, this is the very quick manual way of doing it. We can also choose simplify model, and you can see here we want to take it down to 50%. If you've got a really large model, this is a really powerful tool to handle. There's also a dynamic level of display or detailing. You can just use the auto adjust for this, but there's a few other options under here. So with that, all I need to do is just use that simplify tool to make the model lighter. And then I can start to use the next component in the geolocation tab to do interactive placing. Now at the moment, this one is set up for the MGA 56. By default, you could just be working with LL84. Just depends on how you set up that model. I'm going to keep this on the XYZ IFT coordinate system. You can go to the metric one, but whenever I do that, it makes the model scale differently. So just keep it on the default coordinate system for this simple workflow. It's also going to ask for you to choose interactive placing. So this is like one of the default locations for it to go to, but I'm going to go interactive placing, and then inside of the model, you just place it where you want it to sit. And then you've got tools here to rotate and scale and move the data around. So like all Autodesk products, we have the XYZ gizmo representing your ZY X dragging tools here. Next to the corners of the shape you bring in, you have some orange arrows, and this is going to be your rotate tool. You can also select these and it will bring up some numbers to choose from, so you can actually type in the angle if you want to be more accurate. And you can start to move the data around by looking at the properties of those particular objects. So over here on the right, a little bit hard to see here on the screen capture, but there's the roof height of that building being 515 meters. And then if we want to scale it, maybe we don't want to go back to the architect to change things, we just want to manipulate the sizes ourselves, we can go and type in numbers for our XYZ coordinates, but also scaling as well. So there's all these different tools which you can read inside of Infraworks 360 about the Revit model, and there's certain things that will drive the shape or the sizing of the model. Lastly, there's a uniform scaling arrow here at the top. So if you need to scale it up, you can just grab that and it will scale up the building. And that will work with a lot of in-product Infraworks tools as well. So that's like a common tool to access. So that was part one. That's the simplest and easiest way to bring the data across from Revit to Infraworks 360. The next one is using the internet mapping service inside of Revit. So we're going to go through 5 points here. One is defining the location with the internet mapping service in Revit. If you're not familiar with this, if you're new to the Revit environment, being able to search for a physical address, or even just dragging and moving the location to that address inside of the Bing Maps. You can type in your longitude and latitude coordinates. There's also some other information it pulls down, like weather stations, and then there's options with shared sites. So let's say you've got a lot of models within the Revit application, you can start to set up shared sites and have the building orientated and located based on a shared site setups. So the Internet Mapping Service, if you're new to Revit again, you can go to the Manage tab, and under the Manage tab, you have a location. So it's a little world with a little red pinpoint on it. And like a lot of our applications, whenever you hover over these tools, it will start to explain to you what the tool does. So it just says, this is how you specify the geographic location for the project, and it's going to be using Bing Maps to bring down that information. There's also another option here if you don't want to have to type in the street address or manually search. You can go and choose from a default city list. So you can see here there's a lot of cities already listed out. There's Auckland, New Zealand, and of course there's all the cities in Australia as well. And that will give you your longitude and latitude coordinates and your time zones. So the manual search here, so my site is based in Martin Place in Sydney, 58 to 60 Martin Place. I type that in, search, and it will locate the project address with this little house and the pinpoint at that exact address. So I can do that very easily, and it's going to also locate some weather stations here. If it's not exactly in the right place, I can go into the internet mapping graphic here, and it's just like a Google Maps or a Bing Maps in this instance, and I can drag that pinpoint around to suit. And as I'm dragging it around, it's also going to give me my latitude and longitude coordinates here. So the longitude, latitude coordinates will display, and this is going to be read inside of Infraworks or even Civil 3D if you want to take it across. So this information is important. If you want to write it down, it's a good point to actually write it down with the numbers after the decimal point. And it's a simple way just to move it around. Again, it just uses Bing Maps for the graphics here. And we have weather stations, so there's local weather stations nearby. This will contain some information about the year it was built. I'm presuming it's built or last serviced. I'm presuming 2006 is when this one was built. So up here, it also shows the elevation above sea level, and it's recording the longitude and latitude coordinates as well. This also will assist if anybody's doing mechanical design, if they're doing HVAC design. There's going to be information about dry and wet bulbs and mean daily range of rainfalls. So all of this information is available, being recorded on that weather station, then it's fed back into Bing Maps, and Revit will read that information. The last bit of this is shared site. So this is just if you're working with a number of numerous projects. So in this case, I'm just working on one, and I've got a coordinate system set up for that one particular building. For the one that I'm going to use to export out, I'm just going to use the internal site definition because I'm working with the maps. But if you look here with my SM60MP, this one was set up to be angled 5 degrees to the west, and this is angled from the project true north. Whereas if I just go and use the default one, it's just going to set it up at 0 degrees, and it's going to be aligned to the east. So there's a few things you can do here to set up numerous buildings. Maybe you don't want to export out all the buildings. You can choose which ones you want to work with, and then choose the export with the site definition here. So with that, we can bring the data directly into Infraworks 360 as an Autodesk Revit model. So we don't have to go to the 3D dropdown here. We choose the Autodesk Revit import, and it will come up with a little highlight here where it says this feature requires the Navisworks Manage add-in or Navisworks Manage to be installed. So you do need the suites. And you do need to turn on that tool at the end where I showed at the beginning, sorry, where you have the spanner and screwdriver, and that just means that you can import in Autodesk applications, Autodesk products, and you won't get any pop-ups. The Revit option can take a little bit longer than FBX, so what it does is it converts it to an FBX before dropping it in, and that's why I just wanted to mention the simpler version if you want to go through that. But if you've just got the Revit data, you can bring it in natively, and it will process, and then it will convert into that file format so you can drop it in the model. Now in this case, we're not going to use the interactive placing. We're going to work with some of the default settings in the model. This one is going to work with the LL84 coordinate system, not the map grid of Australia. This is like the default one that starts up all the applications. If you want to know more about all of this, we could connect you with one of our civil engineering experts internally in Autodesk who can explain it probably better than me, but I know like a lot of the data, if you bring it in as LR84 coordinate system, it's easier to work with other applications, whereas if you use the MapGrid of Australia one, then you have to set up the application exactly to match that. So I've got my coordinate system and my positioning coordinate system, and what I'm going to do is, because it's a Revit model, it's already configured, it's ready to go. I don't need to do too much. This is just checking it. It's reading the XYZ information. So you can see here in the Infraworks 360 pop-up, it's at 151.211 blah blah blah, and you can see here it's the same numbers with all the same decimal points inside of my internet mapping service inside of Revit. So it is reading that information between the two products. So this, when you close and refresh this type of internet mapping import, it's going to come into the correct location almost. So it's not perfect. It's not going to be like within millimeter accuracy. It will be within, you know, a few meters. But again, it's another quick way to work with the Revit data. If you haven't set up the project with the project coordinate system, this is an alternative way to bring that data in, and it's going to come in roughly in the right location. So for larger scale projects, maybe you don't need to be that accurate, maybe at that early feasibility study space, this could be a workflow for you. So when we bring it in, it's going to come in, and you can, again, right-click on the model, bring out the properties, and then you can manipulate it to come in an exact right location or move it to the exact right location. So moving into the last workflow here, I do see some questions coming in. So this is in the question bar, and I will attempt to answer some of these at the end. If not, I'll take your details and follow up with an email. So for the last part of this, we're going to be using the project base point, and this is the more accurate connection between Revit and Infraworks 360. So we're going to be working with the MapGrid of Australia information that we'll pull down from either Civil 3D or Infraworks 360. We're going to set up a project base point inside of Revit to match the northings and eastings of that data that we get from the MapGrid of Australia. We're going to be also using tools like Civil 3D to export the data and check that the Revit information is in the right location. Review the MapGrid of Australia settings, and then there's another option here where you can actually clean up some of the heavier data with Navisworks. So maybe you get the information from an application which can't be read natively in Infraworks. Navisworks will read up about 56 different file formats, so you could bring it into Navisworks as an option before bringing it into Infraworks 360. So this is a screenshot of the settings that I have for bringing in Revit directly with the MapGrid of Australia 56. The same process is what I've showed with the other two workflows, where we imported in via data sources. However, when we double click to do the data source configuration, now we're just going to be working directly with the coordinate system being MGA 56. We don't need to touch any of these other settings. We're just going to bring it in, close and refresh, and it will come into the exact right location here on our site. In the first instance though, before you do this, you want to be setting this up correctly inside of Revit with a project base point. Now, the way I've done this is I've entered it in meters because the information I got from the Civil 3D data set and the Infraworks data set was all set up in meters. So a quick note here is when you enter this information, it's a good practice to type it in meters. And what I have is my X, Y, Z coordinates. So in this instance, I'm just using my X and Y coordinates, and I've typed them into the northings and easting settings inside of my project base point. So what you can do is you can move this around to the location. You unclip the paper clip, you put it to the location to the bottom left-hand corner of your site. You type in those coordinates, then you pin it, and you can also have your rotation to true north. You'll see more on this if you are looking inside of your project browser here. So at the moment, this is my site. it's going to be on the 90-0 angle here, but if I go to my true north, it will reflect that 5-degree angle that I put in. And in this case, I'm not using the internal site setting here. I'm going to be working with my own 60 Martin Place setting here for my site setup, and that's going to reflect the angle from the project true north. So a few things just to be aware of when you set that up. Just noted here, you want to make sure that all this information is correct. You enter in meters, you create a site definition here for this particular building. We rename that new site location. You can also add a tag here or a spot, and this will record the information. So at the moment, I've got that project base point selected, and it's revealing the information. Inside of Revit, if you want to annotate it, you can use these spot height coordinates and stuff like that to select the object, and then it will record the northing and easting information there as a bit of annotation. Now, I don't want to just test this inside of Infraworks 360. Maybe I want to double check it. So I've got my Civil 3D application here, and I want to export the data from Revit into Civil 3D and locate it exactly in that real world coordinate. I want to make sure it's perfect before bringing it into Infraworks. So you can export out from Revit as a DWG. So I'm just going to choose my floor plan with the site view. I'm going to go to my units and coordinates here and choose the shared coordinate system that I've set up, and I'm going to set it out in meters because Civil 3D works better in meters. And then by just doing a simple XREF into my Civil 3D environment, in this case for this setup I use the Map Grid of Australia 56. I've also got some near map aerial imagery which works with the Map Grid of Australia as well, so I can bring that in. And I've got my 2D Revit export with the annotation here for the setting out point, aligning exactly with my site. So I can double check this, and I know for sure that this is going to be the right location because I've checked it inside of Civil 3D with real world CAD setup. So finally here for the import, I'm just going to be choosing that Map Grid of Australia 56. I don't need to do anything else here with the coordinate systems. I'm just going to use the main geolocation coordinate system here. Again, I can choose to simplify that model if I want. I'm going to place it inside of Infraworks, and it's going to come in that exact location. Now, one thing to note, this is one of the earlier workflows that I did with a detailed Revit model, and this is me sort of being a bit more complex. What I've found is if you're using more advanced kernel modeling systems, that the geometry may not like it. So it's just something to be aware of, that if you do want all this detail, you may want to run a few tests with more complex system families inside of Revit. Also the textures may not come through exactly the same sort of color or the texturing as what it is inside of Revit. That's because Revit works with a mental ray system for rendering and texturing, the way the whole graphics are set up, whereas Infraworks uses a ray tracer type engine. So one thing you could do is you could take the Revit FBX data into 3ds Max and just use the standard textures inside of Max to get more accurate texture mapping on your model. And as mentioned before in the covering slide, if you don't have the file formats to open inside of Revit, if you've got numerous file formats that you want to try and open and convert and test, you can open it up in Navisworks, and Navisworks will allow you to export out as an FBX. So there's a number of tools here as well for you to maybe work with a heavy model. So let's say for example, you got that 1 gigabyte Revit model and it's absolutely huge. Navisworks is a great application for you to open that model. It also has a tool here for your FBX export where you can do polygon limiting. So you can turn that on and it will reduce the amount of polygons. So before even bringing it into Infraworks 360, you can tie it up inside of Navisworks, you can convert the units, you can include or uninclude the textures should you want to. And then there's different ways of how you locate those textures. So you can embed them in the model, or you may want to have those maps, those texture maps in other locations. You can do all that here with inside of Navisworks. So it's another powerful application to help with the Revit to Infraworks 360 workflow. So just to summarize, this is a short webinar just showing you a basic workflow, but giving you 3 options here. Number 1 was the simplest one, working with a Revit FBX, export it out of Revit, import it into Infraworks 360 using the data sources tool. Choose to simplify it if you want to inside of Infraworks 360, or go to Navisworks. Use the interactive placing tool to position it, and then scale it and rotate it as needed to suit your design or to suit the site. The second option is the internet mapping service, which you can use inside of the manage and location section of Revit. You can define that location by using the service. You can type in and search for the address, or you can just manually move the building around to suit that part of Bing Maps. You've got your longitude and latitude information available, your weather stations, and you can start to create shared sites should you want to with multiple buildings. And then finally, we have the more detailed, accurate option here, and this is working with our map grid of Australia or our coordinate system that we choose, setting up that project base point, adding it in meters, then exporting and running a check inside of Civil 3D, then working with the map grid of Australia for our import settings and the coordinate systems. And then one final option, if you are working with other file formats, is to bring it into Navisworks, use those tools to reduce the amount of data, clean it up using the polygon modeling count tool. You can reduce that and then bring in those large gigabyte models, not terabytes. You can bring them in, but Navisworks is a great tool for you to reduce that polygon count before bringing it into Infraworks 360. Okay, so that concludes the presentation. It is a shorter presentation today because it was just based on a singular workflow, and I can see we've got a few questions here. So what I'm going to do is try and go through them one by one and do my best to answer them. Again, if I can't answer them today, or if you haven't had a chance to ask a question, please send me an email, and I will add that at the beginning here. So for anybody who wants to email me directly, maybe they want to send me some screenshots or they've got more questions, my email is samuel.mcallister@autodesk.com. Okay, starting off with the first question. The question is, does the application support Perth Coastal Grid Coordinate System? That's a good question. It should do. We have some guys living over in Perth who could maybe explain that in more detail. So I'm just going to tempt fate and fire up the application live. The reason I'm saying tempt fate is because it's graphics hungry, so there may be a bit of a lag for people viewing this, but I'll just show you what you can do with your setup here. So we have Infraworks firing it up. It is web-based. It will ask for you to be online. If you're not online, it may not allow you to do a lot of stuff. We've got our model builder, and we've also got our new setup. We can go here, and if I want to maybe just do model builder probably for the first one, we can go here and we can use model builder to pull down some information. So it was Perth, Australia, and in here we can find the part of the coast that we're interested in and then bring that in. So I can either choose this area here, or I could just choose a small part of it. This will actually work up to 200 square kilometers. So maybe I don't want all that information. Let's say I just want, just go down a little bit. I just want somewhere here in the Peel Inlet, and that could be quite an interesting little site. I can do that, give it a name, and I'll create the model. And I'm just doing this all rough as a live demo that's going to my particular site. But you could create one here for Perth as well as a group, and then you can share it with other users. So that's a very simple way to start building up the model, getting some coordinate systems. For the one that I have here, I'll just show you inside the product as opposed to starting up a new one. So here we have Christchurch, but let's say I want to locate it inside of Perth, and I want to go to my model properties. Is it going to come up on screen? Oh, there it is. Okay, so at the moment, this one that I built for Christchurch, I don't know if you can see that, this one is based on the LL84. This one was built using Model Builder, just the little quick demo I just showed you before. If we want to find the Perth coastal system, I'll click on the world there. And again, it should come up, just thinking. So we can go and pick Australia. Here we go, Australia. And what it's going to do is bring across all the different, all the different options for the Australian region. And this should include some options here for Perth. So we go through all the different options. Here we have numerous codes and descriptions to choose from. So what I recommend, you can actually get a trial copy of this application if you're after a particular part of Perth. I'm sure it will be in there. If it isn't, please drop me an email and I'll talk to some of our civil engineers on how to work with the Perth Coastal Grid Coordinate System. Okay, thanks, Sakib. So question number 2, assuming the project has been shifted to a local system with the grid A1 at 0,0,0, how is this reconciled to a global network? So this is from Brent. Brent, are you talking about Revit or AutoCAD or Infraworks? That's probably the question. Yep, Revit. Okay. Okay, so the question, so the local system and A1 at 0,0, how is that reconciled to a global network? So by global network, you mean how does it work with the Infraworks 360 global network? I mean like with a map grid of Australia? Yeah. So you could still, well, the best way to do it would be to move it away from 0,0 to the correct project base point with the northings and eastings. Some people don't like to do that. The option I probably recommend here would be to use the internet mapping system to get it close within a few meters. That would probably be the better way to do it. So I think here, so again, another quick live demo. So what I got here for my one, I've actually working with my coordinate system being based in meters. I can just grab it. Being based in meters here with information I pulled down from my site inside of Civil 3D or Infraworks. You could just go here to your location and just go to the internal site and just use this location here, and that will give you the coordinate system to work to. So that could be a workaround if you just want to use the 0,0 setup. And I do know a lot of people set up their projects that way as well. The whole point of this workflow, the more detailed one, is to try and show how you can actually have the Revit data work with the civil data. Okay, just moving on to the next question. Thanks, Brent. Next question is from Jonathan Taylor. Where can I find a recording of the webinar? Our marketing team will be providing that, so I've got it all recorded. I'll also put a copy on the Autodesk ANZ YouTube channel, which is here. So if you just go to Autodesk ANZ YouTube, myself and the other team members, including our civil tech specialists have put copies of a number of workflows here on the Autodesk ANZ YouTube channel. There's quite a few videos here now, so all our webinars typically end up here as well, but you can also get a copy from our marketing team. I know that some people don't get access to the YouTube channels, so they can be made available directly from Autodesk. But there's numerous other short videos here, so if you want tips and tricks, you want to be able to just find out how to work between several other applications, we've had a number of our civil guys put together some really detailed workflows here on how to use Civil 3D and also Infraworks 360. And then there's some of my workflow videos here on how to work with the Revit data, Land XML data, and work between Revit and Infraworks 360 as well. Okay, the next question, PCG system has to be set up in Civil 3D Infraworks. The PCG system, I'm presuming you're meaning the system I was showing before, the coordinate system. So yeah, you need to ideally set this up inside of Infraworks or Civil 3D. If you haven't set it up, you can still work with the I think it's the world grid datum. Again, I'm not the expert in all of this detail. I've learned a little bit enough to understand how the two marry together. We could connect you with somebody from our civil team or from our surveying team to explain this in more detail. Andrew, if you've got some few more questions on that. The next question from Andrew as well, the parameters can be found on the Landgate website. Okay, I'm not familiar with the Landgate website. It might be a question for us to ask our civil guys who understand this a bit better than me. So Landgate map viewer, okay. Okay, so this is over for Western Australia. Probably what I'll do, Andrew, if you take note of my email address, which is just here, drop me a note because we do have some guys based in Western Australia, and they'll be able to provide you a bit more on this type of setup. So I've never used this one myself before, but it is a Western Australian site. Okay, so just for anybody who has any more questions, they are just down in the question box here, down the bottom of the webinar panel. You can just type them in. If you don't have any questions, I can wrap it up. And if you do want to send me an email, again, it's here just on my cover slide, samuel.mcallister@Autodesk. We'll be following up with this and sharing out the recording, and we'll also be putting it on the Autodesk ANZ YouTube channel here. So YouTube, we have numerous videos that will cover several different Autodesk products. I think we've got about 60 or so videos here. They're very short and easy to grasp, so please check it out. There's even some more stuff on how to prepare the data inside of Civil 3D as well from a few years ago. So thank you very much for joining. Thank you for your questions. I'll wrap it up now, and we will be sharing this shortly. Please feel free to reach out to myself or to the Autodesk ANZ marketing team if you want to get a copy of the video, and my email is there, so please send me an email and I'll do my best to answer you or connect you with some other Autodesk team members to discuss some of the other questions we had about WA. Thanks very much, everybody.